Welcome, everyone. Thank you for joining us today. My name is Jonathan LeBlanc. I lead global developer advocacy for PayPal and Braintree.
And my name is Messerschmidt. I run the developer relations team for PayPal and Braintree within Europe, Middle East, and Africa.
So a lot of what we do as a team is working with new technology that's coming out in basically any spaces that we have ties into, as well as within the biometrics and wearable space. What we do is we take a lot of this technology and apply it into the commerce realm, where we see what's going to be coming up in the future, where we see what startups are coming in the industry, and how we build upon those. Tim and I have been working within the auth space for quite a number of years, through to a lot of the early specifications that's kind of led from password auth and basic auth all the way to tokenization. So what we're going to be looking at today is how auth came to be, how we really have a current standard of authentication and are identifying people, and how that's applying within the realms of biometrics and wearables. Oh,
I'm afraid we don't see our slides.
Yeah, would you mind tossing on our slides? Thank you.
All right.
So really what we're going to be getting into are those elements. We're going to be looking at how we got to this stage in the wearable space, how we're kind of moving towards this area of wearables and biometrics, and applying that into alternate identity methodologies in the commerce realm and in the identity realm, and really where we're moving to in the future.
All right, great. So first of all, thanks for the intro. Thanks for coming. Mm-hmm. And I usually like to talk a lot about security, because obviously that's something that all of us are hopefully hoping for every day, and that all of us are being concerned by. So let me start off with a very simple question in this room. Who of you guys and ladies still believes in security? Do you still think security is a thing? Just raise your hand if you do. Wow, you guys are optimistic. I went to Russia like 3 weeks ago. I was in Moscow, did a speech over there, and nobody believed in anything. They don't believe in God, they don't believe in, I don't know. So, but it was very cold, so people didn't really light up. Anyway, security is obviously something that is a lot of a concept, right? It's very hard to actually achieve total security. There is none. We all, as developers, as companies, we all basically try to achieve security. So we all have to keep track of the recent development within this space. And there is a lot of movement going on. The key issue that we all are facing is every time that we close a door and every time that we fix a bug or an exploit, another window opens somewhere else. It's a constant moving space that we're all in. And we all have to make sure that our users and our user data is being secured and safe, which is a constant battle. It's pretty much like Don Quixote against the windmills. It's something that we can achieve, though, if we keep track of what's going on. So one of the key issues in this space is a very, very old issue. It is the issue of passwords. Passwords usually have three big issues that we all run into on a daily basis. So the first issue that I see is passwords are being reused, right? All of us have done it before. All of us have this one password that seems to come back again because it's very easy to type, it's very pleasant, and we've been using it for 6, 7, 8, 20, whatever years. Then there is the big issue that passwords are being phished. So all of us get those funny emails from Nigerian princes that promise us that we get very rich. So obviously people want to get data from us, and they want to use that data somehow to maybe profit, to damage us. We don't know yet. And then obviously there are keyloggers, which is especially on the desktop realm a huge issue. It's slowly coming to mobile, where mobile exploits, vulnerabilities lead to different malware that's being installed on our phones. So we have to think about ways to help our users. There's a big thing which lots of developers love to have a look at, which is a compiled list of passwords that are being leaked across the internet. So whenever a big hack happens and a company basically is being hacked and all those user information is being put on services like Pastebin, people start actually compiling lists of really popular passwords. They do some data crunching. And there are some great lists by consultancies like Skull Security that pretty much say, Those are the top 1,000 most common passwords. Those are the top 25 most common passwords. So we are going to have a quick look at the top 25 passwords that were being used in 2013. And I like to even boil it down to the top 20. So it's that list. You can find it online. It's done by CBS. Obviously, there's no data for 2014 yet because 2014 is not over. But I promise it's going to be funny anyway. So if we look at the list for 2013, it is not really good for us. So what we see is obviously our users might not be very creative. It is often easy as a developer, as a company, as a corporate, as a service provider, to assume everybody has the same kind of technical expertise as we have, right? We all read on tech blogs, we all read those great books that are being published, white papers, research. We know what's going on. And we all care about our data being secure. Well, the big issue with that assumption is most users don't really care. And most users probably don't even know about this stuff. So they think it's okay if I secure a certain account with a really weak password, because what could go wrong? They put their trust into us, so we obviously have to support them and help them. So 2013 was actually a really funny year, and one company really suffered in there. If you see a certain company name in there, you can shout it out. 150 million user accounts got leaked, and they immediately shot into the top 20 list. So another trend that I actually saw in there is a monkey was 5 places higher before, so people start hating animals. And it must have been a very dark year because Sunshine was on the top 10 before. So people don't seem to be optimistic anymore. Well, we've been obviously talking about reused passwords, and this makes it very clear. If I have lists like this coming up to the top 1,000 passwords that are being reused on a regular basis, top 100,000 passwords, and I use all this amazing cloud power that I have available, eventually I can brute force through a lot of accounts. Let me ask a simple question. Who of you guys has an email address by the company starting with firstname.lastname@companyname.com? So I already have your username, and probably I can find your password in there. So if I really want to get access and you don't have a randomized token, how long is it going to take until I get into your account, right? So that's one of the big first problems that we see. Well, along, just to be even worse, came this thing. April 7th, 2014, a vulnerability in OpenSSL got exposed, which is called Heartbleed. So every provider that used OpenSSL with a certain version, I think version 3, had one big issue. Possibly the memory of the machines that they are using to host all your data could be actually read, which rendered lots of the security mechanisms void, which pretty much means your data and your passwords in there might be exposed to somebody else. So we learned, a lot of us actually changed passwords every few weeks, every few months, because we learned that's secure. A lot of people don't really do that. So even if they get an email asking to change the password, they still don't do. So how can we ensure that our users still stay secure if they don't really secure themselves by choosing randomized passwords, if they don't choose to update their passwords? Well, the first step into the right direction would be using two-factor authentication, right? So two-factor authentication is nothing very complex to achieve. There are a lot of different services that allow us to send text messages and email to our users. So if we have the mobile number, why don't we just send a text message with a randomized token that I have to enter after I want to log in, right? So I use my username, I use my password, I click on login, I wait for the text message or the email, I enter the randomized token that I got, and then I log in. So even if you have my password, that obviously is not great, but still you can't log in into my phone or into my other accounts or into whatever you want to access, unless you also steal my laptop or my phone. So first good step. Obviously, the same would work with companion applications. Google Authenticator is incredibly popular. There's also a service called Authy. I think they all do pretty well. They all offer great implementation details, SDKs. And the nice thing is most of them are actually open source. So they offer one-time tokens to log in. Those tokens expire after a certain period. And I think that's a great first step. But what if we can actually reduce the friction by removing passwords overall? So that leads to a topic that we like to call passwordless authentication. So imagine the two-factor authentication flow without actually ever entering your password before. So you have a simple box asking for your username or email. You click on login. You get a text message with the randomized token. You log in. And boom, there is your service. There is your app. It opens automatically because we can listen for those URLs. And that's great. So we don't even need a password anymore. So even if your server is being attacked, the users might not have to change the data anymore. And for users, they don't have to be very creative anymore. Key issue, obviously, is if I have a password and I don't use a password generator and one of those cool tools like 1Password, I might actually not be able to remember that password anymore. By using this technique, that doesn't really matter anymore. So we really love passwordless authentication, and we thought that it might be a cool thing to introduce into our PayPal and Braintree mobile SDK called V0. So a lot of merchants use PayPal or credit card forms, and they ask you to enter some information in there, right? And in e-commerce, there's this thing they call conversion, which pretty much means I turn a visitor into a buyer or somebody who does an action on my site, right? And this is heavily affected by speed. So what if I reduce the friction? What if I can speed up the process of a login? So what we do is, you see a classical merchant form here for accepting payments, which would look something like that. You have a button saying PayPal or a credit card form. If I click on PayPal, normally you would have the email feed showing up and a password field. And that's great, right? If I have a secure account. And that's good, because people usually take finance quite serious, so there's a good chance our users are secure. But if they have a very secure password, they have to enter that on a mobile device, or where they have to start copy-pasting. So it turns out lots of people actually have the PayPal app installed. So why don't I check if the PayPal app is installed? And if that's the case, I redirect to the PayPal app. It asks for permission to authorize the app once. And if the user chooses to, he can just log in through the existing login in the PayPal app, gets redirected, and he's logged in. The next time he's going to pay, he just clicks on pay, and that's it, because he authorized the payments once, and that's it. So no more password in there, no more inputs, and basically reducing the friction so much is really great. That's what we call the one-touch functionality. And I think that's a very, very nice experience, not just for payments, it's a nice experience for logins overall. So one of the key issues with authentication that I see is a lot of people actually mess that up. The amount of applications that I download from different app stores, I install on my phone, I open them, and they ask me to log in, without really exposing what they really do, is quite high. If I don't know the application, if it's not one of those huge apps that everybody knows, do I really trust them initially by putting my data in there, giving them access to my, let's say, Facebook account, to my friends, to my date of birth? Or do I first want to try out what the app actually does? So a lot of apps actually start creating those artificial barriers where they ask you to log in and they want your social account. And if you don't use that, there's no way to actually see what the app does. And if I don't know about your app, there might be a really high chance that I say, well, that was not really worth it. I go to my home screen, I uninstall the app, and I'm never coming back. You lost a user. Also, a lot of people do the big mistake that they only offer one single sign-on method, so they only go for one social network. And it still makes sense to offer a password flow. Give users choice. People like choice. And that pretty much comes down to the topic of different identities. There are different identities that give us different kind of data. So we have to start thinking about which data do I want at which point. Do I really need to post to a timeline? Do I really need access to a Twitter account? Or do I just want to have the name and the email address of the user, right? So we have to start question, when do we go for which technique? According to Gartner, there are right now 4 big identity providers, which would be Facebook, Twitter, Google+, and PayPal. And if you think about PayPal, this is not really a traditional thing, right? But if I want to buy, let's say, a new TV, and I go to a website and want to log in, we might have a lot of information like the shipping address that might be very beneficial in a certain use case. But if you just have a game, it might not necessarily make sense to log in with PayPal. And that's where we start actually offering things when they make sense. Talking about the technical background, most of this actually started with OpenID in 2005 and an incredibly popular technique called OAuth 1. OAuth 1 got basically produced by the IETF, the Internet Engineering Task Force, in 2007. And it still sticks around. Lots of companies still offer OAuth 1. Anyone in this room ever worked with OAuth 1? Did you like it? Me neither. So the issue is, it is very complex to implement. It is very hard for developers to do that, both on client side and on server side, because it's pretty much a 45 pages of documentation of how to basically do the encryption of different tokens, how long they should live, and so on. And there are not really great libraries that help us. Well, then there was another issue. They didn't really think about mobile devices back then. They didn't think about native apps because OAuth got designed for web. In 2009, there was actually a big issue. They discovered that you could do session fixation, a huge vulnerability in OAuth, which allowed different applications and different websites to hijack tokens, which pretty much meant if your app starts a login process, another app or another website could actually hijack the login and get user data from that. So that's why OAuth 1A got released in 2009. If you've ever wondered, that's why. And gladly, they realized in 2012 that they have to change the whole concept, that it's very difficult. So OAuth 1 had 8 different steps until you could actually access user data. 8 different kind of requests, 3 different tokens involved, which is the authorization token, the request token, and the access token. And that was all very complex. Now, in 2012, they came up with the main framework for OAuth 2, and they reduced that into 6 steps, and they started realizing that people want to have stuff like tweeting coffee machines, a fridge that can have access to my Facebook timeline. A lot of those cool new devices that we all use nowadays, like wearables, that all might want to connect to our existing accounts. So OAuth 2 came along, and I think at least on client side, it's really fantastic to implement. It's very useful and a good technology. It's good advancement of what we have. And a lot of the technology that you see around, like OpenID Connect, actually builds upon on this. Handing over to Jonathan.
Perfect. Thank you, Tim. Yeah, so the days of OAuth 1 were kind of painful. We had gone through it for a number of years, and I remember working with a lot of different partners on the integration, and it was an issue of a lot of the engineers behind it building out complexity where to provide security, but the usability on integrations was very difficult. So for myself, Tim, and a lot of us, OAuth 2 is a big step forward. But realistically, a lot of what we do is all prototyping. As we're moving towards new standards or trying to move towards new standards, we want to build prototypes that showcase what we're doing. Some of them might fail, some of them might succeed. OAuth 2, there's a lot of companies that were behind it that were building upon the standard, and that's why it's so adopted. But you have companies like Twitter that are still using OAuth 1 with pre-verified access tokens, just because that's what they do. And that's what's secure. But building on what Tim was really talking about, what we're trying to do with the tie-in, with identity, with authentication, with every piece of technology that we're building is a migration away from passwords. So I'm sure a lot of us have seen this. How many of you in this room have heard friends or family or someone on Facebook or some social network that says they got hacked or hacked and their accounts locked? Yeah. A number of you, yeah. So most of the time those hack attempts are just because, hey, they're at the Apple store and check their Facebook and forget to log out. And someone just logs in, starts posting things, or they're using one of those simple passwords. And no matter how much you secure a system, if you have a password that's so simple to guess, very easy to access in. We can do things like regional determination of where you're logging in, where the user always logs in within, let's say, California, and all of a sudden they're coming from the Ukraine. Yeah, maybe there's some verification that we can push out to make sure it is them. But then we have to push a second factor of auth, which is one of those tokens that we can push to an email, or we can push through your phone. And really, everything that we're building upon with identity and authentication is all building upon, right now, the mobile device as the center point for everything that we're doing. And as we build into wearables, wearables are tying nicely into the mobile space. So as we see the technology building in the wearables, and even beyond there, and we'll get into those in a little bit, they're going to tie very heavily into the devices we already use. And realistically, social accounts are one thing, but the one thing that we really have to look out for is when we actually have to secure important data about ourselves. So you lose your social account, sure, you're going to lose your photos, you're going to lose your account, you're going to use a lot of the access that you have, but most of the time it's not going to destroy your life. Think about it on the account side with credit cards, with bank accounts, with identity fraud. All of these aspects are truly issues that can affect your concrete life. And these are the things that are vastly important for us to secure, which is exactly what we try to do on the PayPal side with the identity systems. We secure storage of credit cards within our vault capabilities on both Braintree and PayPal. And really what we're trying to do is provide a methodology towards using digital accounts or digital commerce and providing that as an easy tokenized string that you can just call out to pay for something using that methodology or that method, that credit card, that bank account, or what have you, and you do it securely, avoiding a lot of the PCI compliance issues because you're offloading it to somewhere else for security. So this is really where we're trying to get to with a lot of what we're doing, is providing a secure auth mechanism to secure your real concrete life. And that's really when Tim's talking a lot about the concrete versus social identity. That's what we're talking about here. Your concrete identity is the stuff that can really harm you in your real life. And this is where we have to spend a lot of time. But as we start going from the aspects of authentication and really logging people in, identifying them, making sure that their accounts are secure, what we have to really look at is how that's going to apply in the wearable space, in the biometric space, in the embeddable space. And the biggest problem that we see time and time again, every time there's a new piece of technology, companies build out proprietary methodologies for how to work with it. But realistically, in the identity realm of tomorrow, in the auth realm of tomorrow, what you want is a centralized specification or centralized methodology for people to be able to log into multiple different systems. Sure, on my on a Samsung watch, I might want to tie in some biometrics feedback, but I might also want to tie in something from another wearable device or a sensor or something like that. And having a streamlined way of doing that is going to be a vastly important aspect of the future of auth in the biometrics and wearable space. And that's where organizations like the FIDO Alliance come in. So this is one that we sit on the board of, as well as a lot of other technology companies, as well as a lot of large banks. And what they do is try to provide a streamlined specification for how to authenticate a user, and primarily within the hardware and wearable space. But realistically, it can be used anywhere. And we have a lot of the technology that's coming up in the wearable space and the biometric space that's already supporting this type of method. And it's really not just building your entire auth system to a spec like what you would see with OAuth or OAuth 1, OAuth 2, or any of those types of specs. It's supporting an idea of being able to apply your auth system, whether that be from biometrics or some hardware feedback, directly into to any system that might want to integrate it. So that's where systems like this take our concepts of prototyping in the wild west of wearables and moving it into something that can be used in any type of environment. Because, I mean, you have Samsung and other companies that are building upon, betting on the watch or the wrist. You have companies like Google that are betting on the face. You have others that are betting on biometrics feedbacks from veins. And, there's a lot of companies that are betting on different things. And we need something like this out there to kind of streamline that approach and allow us to build out a way for integrating with everything. So this is where we actually get into the aspects of applying wearables, applying that auth methodology into a mobile extension, and really seeing what technology is happening right now and how it's going to apply into a commerce of tomorrow. So one of the big ones that is being integrated by a lot of companies, ourselves included, is Bluetooth Smart. It's also known as Bluetooth Low Energy. Bluetooth Smart's the marketing term that they use for it. Realistically, how many of you have heard of Bluetooth Smart before? Oh, good. A good number of you. For those who haven't, it's part of the Bluetooth specification. Bluetooth 4.0, when they released that, Bluetooth Smart was included in there. So we're all familiar with Bluetooth because it's deeply ingrained with everything we do. We have every device connected into it. But where Bluetooth Smart differs is, instead of saying, let's say, streaming data or video, music, what have you, it's instead saying encrypted packets through. So that's decoded on some hardware device out there, but it's really smaller packets. The lifetime of a battery using Bluetooth Smart is much larger. The range on Bluetooth Smart is a little bit lower. Instead of about 100 meters or so, and Bluetooth offers, it's probably around 50 to 70, depending on how you configure it, 50 to 70 meters. So realistically, what it's being used for is the aspects of being location aware. So the way it's going to work is, let's say you're going to have a centralized device, and since it's Bluetooth 4.0, our phones, our smart devices, they already have the technology built in. So most smartphones will have this built in. So a lot of what companies like ourselves are building upon is building upon mobile as the center point device for this. Then the mobile device will in turn connect to what we call a peripheral bridge. Really, it's a tiny piece of hardware that allows the binding of the hardware or a location awareness to a phone, a centralized device. And in turn, that bridge is communicating with some website, some web server out there that's providing some data back. So at the end of the day, even if you're under a ton of concrete and you can't actually communicate outwards, you don't have a signal or what have you, you can still connect to a peripheral bridge, and that can in turn provide you internet access for doing whatever you might be doing, like shopping. Let me give you a practical example, because this is probably a little bit convoluted. Okay, so here's how we do it with what we call PayPal beacons. The user is going to walk up to a store. They have the PayPal application installed on their mobile phone. They walk into the store, and the beacon or the peripheral bridge will actually wake up the PayPal application saying, would you like to check in? And if you say no, the merchant, PayPal, will have no idea that you're even there. There will be nothing transmitted on personal data. If you in turn say, yes, I would like to check in, the bridge or this little beacon that you might plug into a wall or a laptop will bind itself to your mobile application and provide a nice bridge towards PayPal servers. So you check in. You walk around the store, you pick up whatever you want. You go to the cash register, or you go to someone that's walking around the store with a phone or tablet, and you say that I want to check out. Now, the merchant themselves, what they receive on a point of sale device or whatever they're using is a photo of you, your name, and the ability to check out with PayPal. Now, where that becomes valuable is that you don't take out a wallet. You say, I want to pay with my PayPal account, and it pushes the payment directly through. And it's all through visual cues on the merchant side, playing with trusted vendors in the point of sale systems. There's plenty of other beacons out there that are doing a lot of the same thing, building on location awareness. So this is where the technology today is building towards. And where we want to get to is removing that hardware piece in the middle. Because realistically, a mobile device can do the exact same thing. If we're tying to that, it could be a mobile device, and we're all using that. Biggest problem that I see with a lot of technology that tends to be released, in the hardware space, is that they introduce some whole new piece of hardware that that a lot of companies have to start integrating with. Now, that's great on the prototyping stage where you're actually first building out this concept because of consumer adoption. On the merchant side, it's not bad, but when you start enforcing a lot of consumers to carry another hardware piece, they're just not going to do it, because you're not only just enforcing a new standard and something new for them to adopt, you also have something else for them to carry around. But when you're building upon the mobile device that they carry around with them every single day, that they will not, that the first thing they check when they get out of bed, I know that's what I do, that's exactly where it starts becoming valuable, because you're building on technology that people are already carrying around with them day in and day out. Then you have on the wearable space a lot of prototyping that's going on with boards like Arduino boards. These two here, the Flora and the Gemma, are two specific ones that are really kind of cool. We've been playing with them a little bit. They have a lot of integrated sensors, expansions, and things like that. It's just like you would see in a normal Arduino board or anything like that. But what they're built towards is sewable and embeddable technologies within, let's say, hats or clothing or what have you. And where this becomes kind of cool is on the prototyping space, because a lot of people right now, they're using them for tying into, just LED lights that can light up things on the shirts. We've had a couple of our advocates do the same thing within conferences and, just light up parts of their shirt. But the integrated sensors can be used for a whole bunch of different things. Think about clothing of tomorrow and being able to wash this hardware and embed it within clothing. And as it gets smaller, tiny little IoT microcontrollers embedded in, it could be the clothing of tomorrow that ties in with skin responses or identity or authentication, because the sensors are directly built in. Now, of course, we have a lot of prototyping that goes on in our team. One of our advocates out in Sydney, he decided to start playing with this. So what he would do is he'd tie in these LED strings to one of these devices, sew it directly into his shirt. Of course, what you do not want to do with a lot of this prototyping is light your shirt on fire like he did. This is a lot of the rapid prototyping that we end up doing. Some of it ends up like this. We make some mistakes. Shirts get folded, things catch fire. It was funny because it wasn't on him. Otherwise, it would be very tragic. But a lot of the prototyping that we're going to be doing, that we're doing with this is just that. We're going to make mistakes, and that's okay. And that's really what's the biometrics space, where the wearable space really represents, is us taking leaps forward in the hardware space to build upon these sensors, build upon these modules to extend upon, using the human body as the mechanism for auth. Because when you start doing that, you remove the necessity for passwords. You remove the necessity for users to think about their own security, because it's building upon themselves, things that they can't really control. That's just a part of who they are. And towards that, that's how you start uniquely identifying people with these sensors. There's a lot of cool things that are going on right now.
So as Jonathan already said, we have this big landscape of different wearable devices, embeddables that we have on our bodies, that we have pretty much everywhere. Our smart home, our smart car, our smart coffee machine, anything. So why don't we actually start utilizing all those different devices and creating mesh networks out of them, creating an intelligent environment around us? I'm not sure if you guys have seen the Google I/O keynote, but they actually mentioned trusted environments, which I thought was brilliant. So the idea is really simple. If I'm at home, if I'm in my home Wi-Fi, if I have my watch right now connected to my phone, and if I probably even wear my smart glasses, my phone can pretty much assume it's me, right? It's Tim, because my watch that I usually don't give away is really close to my phone. It's connected. My glasses are connected, and I'm in my home Wi-Fi. So if that assumption is correct, can't we actually start scaling security around that? Can't we start creating basic assumptions? So if I'm sitting on my couch and I'm watching TV and I want to tweet about this really bad episode of Family Guy or whatever, or I want to explain everybody how awesome the Red Wedding at Game of Thrones was, why can't I just pick up my phone and, since all those things are connected already, just keep logging in? Do I really have to enter my PIN because my phone is normally secured? Or can I just take a basic assumption, since I'm at home, I'm in a secured and trusted space? Now, obviously, if I go into a coffee shop and I want to buy a coffee and I'm not in my home network anymore, we can start scaling the security, and we can do something that I like to call N-factor authentication. So because it's a very simple use case, I might want to buy a coffee for $3. I might want to enter a 6-digit PIN. Now, I continue my travel, I continue my trip, and I go to some electronics store. I want to buy one of those really shiny new TVs. So probably I want to enter my PIN and afterwards get a token, a one-time token, via email. So I enter that token and then I authorize a payment. Now, obviously, if I go to my car manufacturer and I would do the mobile checkout, whatever, probably Tesla offers that already, obviously then I might even be interested to enter something else, again, to make sure it's really me. So depending on the use case, we can actually start scaling security. We can really define various different scenarios where different authentication mechanisms are applicable or not. And I think that's something that very much sounds like the future, right? But the thing is, we can actually start realizing that right now. And Jonathan is going to elaborate a bit on that.
Thank you. So this is where we get into some fun. Let's go look at some biometrics and see how they're applying into this world of auth for tomorrow. And when you really look at these things, you want to think about them in the concept of how they might tie in with a mobile device. We're going to start introducing them as what is currently around. So if you have a Samsung Galaxy S5, PayPal actually does have a nice integration within the fingerprint scanner. So scanning in or swiping your finger in order to auth yourself within PayPal. This is one of the mechanisms that we started looking into and working with in the auth space and starting to use for your fingerprint and biometrics for scanning. But this is just the basics on what we can do. There are so many different biometrics and sensors that are out there where we could have some fun and really start building out some just amazing auth technology that has vast more security than anything else that's out there. That's where we start looking at some of the technology of tomorrow. So how many of you have seen things like vein recognition biometrics? Yeah, a couple of you. Okay, this is really cool in the payment space. So what they do is they use an alternate light source on your palm. You'll put it down on a keypad, or you can put it on basically anything that can scan it. They use the alternate light source in order to recognize the blood moving through your veins, and they use vein uniqueness in order to auth yourself. So that becomes your authentication mechanism that you can apply towards logging you in or tying you into your digital currency accounts and being able to check out. Now, there are a couple of companies out there that are working in this space, actually, quite a number of them. And the funny thing is, most of them push one point of security towards this. So for those of you who are like myself, like Tim, who like to watch action movies, like to watch spy films and James Bond or what have you, you're probably thinking, what if someone cuts off their hand and starts using it in the sensors and starts stealing their digital currency? Well, that's one of the security measures. Since it is recognizing blood flow through your veins, one of the security measures is that you actually have to be attached to the rest of your arm. So that's actually kind of the funny part about it. But since it is measuring blood moving through veins, small cuts, dirt, what have you on your hand doesn't matter in the reading. So this can be tied within mobile devices as a centralized point of second factor auth. If you want to use this plus a hardware token on your phone, it can be used as a potential build into another wearable device. There's kind of an endless realm of things that we can do with these biometric sensors. So there is this company called Quickster. They're one of the ones that is working on this technology. There's, again, a number of them that are out there. But they're using it in the commerce realm. So you can walk up and use one of these kiosks or one of these little checkouts and just use your palm as the auth mechanism. And this is really where we get into some cool things, is using what's external towards your body as the auth mechanism. There's also this one company based in Toronto called Bionym. They're working on basically a heartbeat identification system. It's called the NYMI. NYMI. They're really cool. I chatted with them a little bit recently. We have some of their devices on pre-order. They're just about to start shipping their hardware out. And what they do is measure heart rate uniqueness. And I was chatting with one of their evangelists last week at an event in Vegas, and I said, well, what happens if you're under duress and your heart rate goes up? Or what happens when you've been running, and can it still identify you? And apparently it can. So it's measuring a unique pattern in your EKG, and it can use that. And it's a smart system, so it learns different baselines for yourself as you go along. So it has less false negatives. And really, when you're looking at biometrics and you're looking at auth systems, there's one thing that you really need to keep in mind, and this is what you should be looking for when you see any biometrics feedback. It's not the aspects of false negatives, and that's basically, let's say you use the fingerprint scanning on the Galaxy S5, and it fails to recognize it. That's a false negative. You're a valid user, and it didn't read it, or you missed the thumb swipe. What you really have to worry about is false positives. So that's the rate, the percentage rate that an invalid user scanning might be recognized as a valid user. That is the aspect of biometrics and auth systems that you really need to be careful about. So watch out for that and use that as the identifying factor when you're looking at biometrics feedback. There's also these really other cool technologies around attachable computers, because sensors are becoming really tiny, which leads itself towards building things like this. There's also other companies out there that are building this into tattoo art. So you have sensors that are attached to your body as tattoos or tattoo sleeves or what have you, and it makes it more of a fashion statement. And a lot of you who play with the wearable space know that it's not just about being the best piece of technology, but also making it aesthetically pleasing that people actually want to wear it. But this company is actually called MC10. So they build all these sensors in there for medical reasons, for building out sensors on your body that can report back to a mobile device on a doctor, for a doctor, so that they can monitor you at any given time. So this could be the future of what you wear when you're in a hospital. Direct feedback mechanisms and sensors that allow people to walk around and not be tied to a whole bunch of machines. So let's go into a little bit about the future of authentication. Now, a lot of you this might come by as a little bit creepy, so bear with me because we're going beyond wearables a little bit into embeddables. Because there's a lot of medical technology that's kind of paving the road towards what might happen in the future and where these wearable devices, as they shrink down, might end up. So the system called implantable myoelectric sensors that is being built up. This one is built up by the company who wanted to help prosthetics, helps the prosthetics industry, because what they were saying is that after World War I is really where a lot of the prosthetic advancement had happened, because of the war, and it hasn't changed all that much since. So what they wanted to do is provide a better mechanism for not just having maybe a closing, your hand closing or turning and not being able to do both at the same time, but providing a true new limb to people who might have lost it. It's a really cool advancement. So what they do is they realize that there's still electrical signals going through the muscle tissue of a lost limb, phantom limb syndrome you've probably heard of, and they can utilize that by embedding sensors directly at the end of the muscle tissue and tying that directly into the prosthetic. Now think about this. You have these embedded sensors whose lifetime is approximately 80 years that you can embed inside a human body for controlling that. What if you took those same sensors and built those into something else, a mechanism for authenticating yourself, or being able to uniquely tie into someone's DNA and test that as an auth mechanism to uniquely identify you? That is where some of the possibilities around biometrics, mobile tie-ins, and everything that we're doing might be going. And these are some of the cool spaces that are coming up. There's also a couple of companies that are working on embeddable implants. This one is, well, let's see, there's one called Dangerous Things. Now this one gets into the whole realm of creepy, so if you're not used to creepy, don't go to this website. But they have embeddable NFC and RFID chips that you can embed directly right there. The reason it's creepy is because they sell scalpels and extraction tools along with that. So yeah, but what it's showing is that this technology is potentially possible embedded within the human body inside these tiny little capsules that can live there. And being able to auth yourself from inside the human body and being able to open doors or to unlock computers. And it's the same thing that wearables can do right now, but it's embedded within the human body. And it's amazing the amount of battery life that these things can actually represent. And as we see new technologies like what Freescale Semiconductor is doing with these tiny little IoT, Internet of Things microcontrollers, these things might be the future of embedded in our embedded devices. They might be the future of what's inside us. It might be a future of our wearables. And these are specifically designed towards connecting different hardware. So an embedded sensor might tie in directly with a mobile device. So there's a lot that we can see that's happening in the world of tomorrow, in the world of biometrics, the world of wearables. There's a lot of cool things that are happening now, but what it needs to do is provide a benefit back that's not in this creepy realm, because people will not adopt things out of this creepy realm. It just will not be applicable in the same way where wearables need to have, and we need to be aesthetically pleasing, because that is the world that we live in.
All right, so pretty much summarizing what we just told you in this whole speech is we have this variety of different new form factors that we all might be used to, like a wristband or glasses. And then this whole new thing, embeddables, which might be coming up, might not be coming up, depending on the creepiness. But also, obviously, leading us to this world of possibilities of actually identifying people through just using different devices on their body, enhancing people through these things, and obviously also authenticating them. So not asking for passwords anymore, because we can start not just assuming somebody is you, actually we know it is really you. And that's something that might be helpful in some use cases and might be very dangerous, obviously, in other use cases. So we'd really like to thank you for your attention. If you ever need to reach out to us, find us on Twitter, find us on braintree-payments.com/developers. Email addresses are over there. Thanks for your attention, and we'd be happy to take some questions.
If you wouldn't mind, we have the mic set up on either side, just so that the recording can get it. Or if you're in the front, we can repeat the questions.
Hello?
Hi.
Okay. Yeah, I'm wondering, when you talk about, say, biometrics, depending on where the, say, the template of your biometrics is kept, right? There must be a way that people can hack into, say, the back end and alter that. Then your identity would no longer be matched. So what kind of security measure have people been thought about that? Because if you change that, then there's no recourse, right? Unlike a password.
So this is actually a major issue that's been coming up recently with embeddables. So let me give you, for instance, the Gates Foundation is supporting this one company that is building out an embeddable medicine deployment system, deployment chip for contraceptives. It's not to be used really for first world nations, but in developing nations where they might not have a regular means of controlling family sizes. And the main concern is that the deployment of the medicine is controlled through a mobile device where the doctor can say, hey, I'm going to turn on your contraceptive for this month. This is the entire concept of revenge pregnancy is what a lot of people are putting in the news on that control mechanism. But that is something that's coming up a lot in this space. But that's where you tie in with systems like OAuth 2. That's the mechanism for tokenization on the security side for the web. The same thing has to exist within the hardware space of securing that connection directly to a mobile device and authing yourself within the system.
Actually, I'm not even talking about those futuristic stuff. Let's say the iris. Iris is more accurate than fingerprint, right? So it's can uniquely identify you, and also it doesn't change, as you age. Unlike heartbeat, which people's condition can change, right? So what I'm saying is, unless that you're doing authentication to your device, for instance, some of the countries they have a national ID and they use fingerprint or iris, right? So suppose somebody hack into their backend database and change that biometrics, what they call that the template, and then no longer you are you, right? Then how do you prevent that? I mean, that kind of hacking is bound to happen.
You're absolutely right. And when you're looking at this space around utilizing biometrics for the security mechanism, these are elements of security which we really have not explored before. That's in the biometric space, we're just starting with fingerprints, which have been around for a very long time. When you have biometrics tied towards identity, it brings up a whole new concept of identity theft. But it's all upon the security of these national databases and really what you're working on in the biometric space, and being able to basically have a feedback mechanism on yourselves and have multiple different forms of authentication. That's really where two-factor auth comes into play. So you have 2 passwords plus maybe a hardware token or something like that. But it's important to have multiple different points of commonality or identification that are going on beyond just the biometrics until you have a secure enough system. So, not solved yet. Major issue that we have to work on, or that has to be worked on in this new technology. But it is one that everyone that's building in this space is aware needs to be solved. Yeah.
Thank you.
We can bring up and chat with you right over here.
Yeah, please find us at our booth, and also we really appreciate your feedback. So please come over to our booth and also use the conference survey mechanism. Only if you have a good opinion about this.
So thank you very much, everyone.
Cheers.